So let's take a look at a complementary concept to listening to player input, I think. So let's get into signals. Okay, so using signals. What are signals, right? Signals are a delegation mechanism built into Godot that allows one game to react to a change in another without referencing one another. The using signals limits coupling allows your code to be flexible. Okay, I get this one inherently. This is similar to event processing. Um, so it allows you to not carry many references to other objects in the game. Rather, we just basically register a callback handler to handle events or signals that happen in the game. And why I said it was complementary to listening to player input is because I think one way to handle player input um, in the previous exercise here was that we basically in um, computer science we usually call this polling, right? We call it polling for a for the event, right? We're basically making a query to see if something has been pressed during the time when this code is being executed, right? And then get this code was executed all the time, every cycle on the game's main loop, right? But using signals is different because um, using signals is basically like not having to depend on the loop executing code and then you explicitly querying or polling for the signal if this is happening, if that is happening, right? Basically this one you just register a callback and the game engine will automatically call your function when the signal happens. And what this just allows you to do is that you can free yourself from writing huge lists of if statements, like if this signal, if this signal, if six signal everywhere, right? You can basically just register a callback, and whatever it happens, it happens, and you will be able to react to the signal. Okay, so here's an example. Like for example, you might have a life bar on the screen that represents bit health. When the player takes damage or use a healing potion, you want that bar to reflect the change. So to do so in Godot, you would use signals, right? Like methods, callback signals are this is a it's a class. Signals are first type object types in Godot 4, meaning this, you can pass them around. Good, you can pass around signals as variables and references. You can pass them to functions. You can hold them as references in your class. Okay. So, and then there's also a complementary signal class reference for a list of what you can do with a signal type directory. Okay, not directly. Um, okay. You might want to look into the observer pattern. It is an object oriented pattern. It's used very commonly in application development. Now you can say, okay, we will now use signal to make a Godot icon from the previous lesson. Listening to player input, move and stop by pressing a button. Okay, so this is exactly what they're saying. They're saying let's do it. Let's do the last lesson in a different way using signals. Okay, scene setup. To add a sprite to our to add a button to our game, we will create a scene which will include both a button and the sprite scene we created in creating for a script lesson. Create a new scene by going to the menu. Okay, let's set up a new scene with the previous project. So let's switch to our Godot here. In the scene menu, we click here, new scene. And it's going to be a 2D scene. And we're going to attach our previous Sprite 2D TSCN saved scene into it as a child. Okay, so I think that creates it as a child. So if I drag it in here, I think there's two ways to do this. You can right click on this. It says add child node. But actually, it's interesting whether this is the same because this is not a node. A scene is not a node. So let's see what happens. Right? Drag it in here. It creates a sprite 2D as a scene underneath it. And is that the same thing as instantiate child scene? I wonder. I'm going to click this and undo it. It is, isn't it? See? It adds this. So if I cancel this and I delete this, yeah, if I delete this one and I do it this way, instantiate child scene, and I select that, that is essentially the same thing. Okay, I guess it's just a different way of explaining it. So, okay, okay, it does say instantiated, right? So that's the same thing. I guess dragging it in is just a shortcut. We want to add another node as a sibling of the 2D. Okay, so right click a node, and what we want to do, we want to add a button. Okay, so let's add a button. A sibling. So we go up here, add a child node, button, create. All right. So far, so good. The node is small by default. Drag, click and drag on the bottom. Okay, and to resize it. If you don't see the handles, ensure the select tool is active in the toolbar. Okay, click and drag the button itself. Move closer to the sprite. You can also write a label on the button. Okay, we can label the button. Your scene and viewport should look like this. Okay, so let's do that. We have to get to here, and then now how do you get back to the whole scene view? Okay, kind of. Oh, right. You have to go back to the 2D grid view, which is up here. So the button. Let's just zoom in a little here. Where is that button? Okay, so it's very small in here. So I think we gotta use to pan the page. Oh, is this one? Pan mode. Yeah, okay, pan. We gotta pan it. There's the button. It's still very small. Okay, so it says expand it. Okay, put some label on it. The text we can say uh, toggle something, and then move it closer to the sprite. That's okay. Put it right here, and okay. You save your new recreated scene as node 2 new 2D TSCN if you haven't already. Okay, so save it. Control Command S. Node 2D TSCN. Save, and then run the scene. So click on this one. We know that we don't have a default one yet for this project, but we have. That's why we click this button. Run current scene. There we go. I think we can click the button, but of course it doesn't do anything yet. This the icon still moves around, right? The character still moves around with the keyboard, but the toggle button, of course, doesn't do anything yet. We haven't attached any signals to it or signal handlers. So what we need to do is connect the signal in the editor. So here we want to connect the button's pressed signal to our sprite. And we want to call a new function that will toggle its motion on and off. We will need to have a script attached to the sprite to the node, which we do from the previous lesson. You can connect the signals in the signal dock. Okay, so we basically go into the button and look for the signal dock, and then there's a bunch of signals that are advertised here. We're looking for the pressed. So I guess all different types of objects can expose different types of signals that can be that the button can generate, and you can connect to functions, function callback handlers for those events, for those signals. So double click the press signal to open the node connection window. Okay, and then I think it just wants you to define the receiver method, like pick one or create one right here. So let's try that. So click on the button, and then here there's a signal tab. Button pressed, click on that one, and there's a button say connect here. So we click connect. We'll select our sprite as the receiver, and the receiver method says on button pressed. So let's connect them. And so I would believe if I look in the sprite 2D now, the GD script for the sprite 2D, however we get there. Okay. So what is this? Okay, so if we do that, how do we get to the script? What is blocking me from? So what does it say here? Okay, there connect node. The node needs receiver method. A function. Okay, by convention. Okay, so, but what happened here? One only allows you to connect. Yeah. Okay. Click the connect button. Okay, we did that, right? Jump to the script workspace. I don't think it jumped to this. Oh, okay, it did jump to this. Okay, sorry, I was on here. It just doesn't look like I was. Okay, so it doesn't get highlighted. The tab doesn't get highlighted here, which made me a little bit confused. So it says click on this. Source is the button. Signal is the pressed, and the target is sprite 2D. So that's a table of um, all the connections there. Let's replace the line with pass keyword with code that will toggle the button's motion. Okay, how would it toggle the button's motion? As sprite 2D moves thanks to the code in process, we know that, right? Godot processes a method to toggle processing on and off. Node.setProcess. Another method for the node class is processing. Returns true if the idle processing is active. We can use the not keyword to invert the value. Okay, set process. This function will toggle processing and in turn the icon's motion on and off upon pressing the button. I think what is this going to say is node set process must toggle something internally, right? If you set it to false, then it's no longer to call the internal underscore process function when it usually does, right? It's going to turn it off, so none of your custom code that we defined earlier will ever get executed, and that's why we won't be able to move the character anymore. Okay, so let's just copy this code here. There we go. Save. Before trying the game, we need to simplify our process function to move the node automatically and not wait for user input. Replace it with the following code we saw a few lessons ago. Okay, before we do that, let's just test it out. It's not going to move automatically. It's going to remove based on my keyboard inputs, but it doesn't really matter, right? In this case. So I'm going to run this scene, and I'm going to tell you truthfully that before I click the button toggle, that I can use the keyboard and move this character around. My expectation is that after I click toggle, I won't be able to control this anymore with the keyboard. So I'll click it, and now I'm right. So now I'm pressing on the keys, and nothing's happening with the character. And if I press it again, it should work again. There we go. Now I was right. Oops, I added some skew the last time. Okay, very good. So I think that proves the point. I don't even think we need to go further with this one. Um, But for the case of if this is setting up something for the next lesson, then maybe I should copy this. Let's do that. The process, let's copy this one, simplify it. To make this will make it automatically move, right? So I don't know what the commenting characters are. I think it's in. I hope it's like this, like in C. No, it doesn't. It doesn't do that. I think it's just pound for the comments. I wonder if we can do a multi-line select. No, it doesn't work that way either. Shift Control Option, maybe like this. No, I want to select multiple lines in that same position. Okay, I guess it doesn't know how to do that yet. So let's just comment everything out. Comment all this. Okay, and then I'm going to paste in. You know what? Okay, I could have just renamed this function to something else, right? I should have thought of that. Okay, so this is the only code that's in here, and when I run it, it automatically moves around. If I click the toggle button, it stops. I guess that's a more nice way to show you guys this working. All right, so that's signals. Let's see what the summary says. This closing note, I guess, and any node in Godot emits signals when something specific happens to them, like a button being pressed. Other nodes can connect to individual signals and react to the selected events. Signals have many uses. With them, you can react to a node entering or exiting a game world, to a collision, to a character entering or leaving an area, element of the interface changing size, and much more. An example is an area 2D representing a coin emits a body enter signal when the player's physics body enters collision shape, allowing you to know when the player has collected it. So that's a very good way to put it, because especially when you got all these different possibilities of things that can happen, it's nice to have a signal being sent, and only objects that are interested in it will connect to it, right? So it makes coding, event handling, or signal processing a lot easier. Like things you're reacting to things that are happening on the screen in the game. Only objects that are interested in those events should connect to it, right? And so that makes the coding a lot cleaner and simpler. All right, so the next episode, we're gonna get in right into creating an actual 2D game, which is very exciting. It's gonna bring all these concepts together and a little bit more. It's gonna show how to structure the game and other other things like that, like how to strategize and put together a project that will be good enough for an actual game. So I'm very excited about the next one. So see you in the next one.